Assalamualaikum to all my fellow audience. Today I would like to present about my FYP thesis research. Due to pandemic situation, I have to share my FYP thesis to a review paper which titled as a review on effect of Anthocyanin as a natural pH indicator to bioplastic, credited to my supervisor, Dr. Rizala binti Yusof. This is table of content, consists of introduction, literature review, and conclusion and recommendation. Let's move on to the background of study. In 2015, the overall production worldwide of all petroleum-based polymers surpassed 332 million tons. However, with increasing oil prices and minimal petroleum assets, researchers are making immense efforts to discover a viable solution to petroleum-based plastic. Traditional plastic are typically non-degradable and not ideal for the ecosystem. Nowadays, plastic processing is then moved to a bio-based plastic from biological sources. For the problem statements, the typical synthetic plastic usually made out of petroleum, which is non-biodegradable materials and cannot be renewed easily. The transitions of synthetic plastic into a bioplastic is one of the initiatives that may solve this issue. Anthocyanin was used as a natural indicator to enhance the bioplastic properties and indicate pH changes of food. However, specific effect of adding anthocyanin to the properties of bioplastic is still and need to the further review. This study is to review bioplastic and identify the biodegradable property. The use of natural pH indicator would help the consumer predict the freshness of the food. It can contribute to the safety and health of the people. It also helps the industry develop a new intelligent and enhanced packaging systems. It can produce significantly fewer greenhouse gases emissions and increase the food's shelf life. It also can contribute good benefit to society and environment. The objective of this study is to focus on the chemistry of anthocyanin as well as to focus on the effect of anthocyanin as a natural pH indicator on the biofilm thickness, mechanicals, and barrier properties. What is the pH indicator? It can be described as a chemical compound added in a lesser amount to a solution. In the Arrhenius model, a pH indicator is a chemical detector for a hydronium ion, which usually allows the solution's color to change based on the pH. The Henderson-Helmholtz equation is derived from the acidity constant. From this equation, if pH equal to pKa, the ratio of both species would be 1:1 ratio. If pH is greater than concentration of acid, then the persistence of conjugate base will show the color. In many plants, there is a color pigment that can act as a natural pH indicator. What is anthocyanin? There are water-soluble pigments in the class of flavonoids that have been shown to have a higher antioxidant potentials than vitamin C and E, according to Suta and Sara 2020. They are commonly found in vegetables and plants such as red cabbages, sweet pepper potatoes, butterfly peas, and cranberry. Anthocyanin color vibration is due to the different chemical structure. Under strong acid condition, a helium cation will form at pH 5 to 6 to color system. Chalcone and carbenoxidil base are formed, while at pH range 6 to 8 and pH greater than 8, blue or purple colloidal and hydrobase and light yellow will be formed. What is plastic? Okay, according to Behati 2020, bakelite was the first completely synthetic plastic in the world, invented in New York by Leo Bakelite in 1907. At the beginning of 20th century, the potency and superiority of plastic lead to environmental issue as to slow decomposition process as being dumped as a trash. A significant effort was made to recycle this problem at the end of the century. The introductions of bioplastic to food and society has widely occurred as it can further be grown and become industry demand for such packaging products. Polysaccharides are the biopolymers used to produce environmentally friendly bioplastic. What is actually bioplastic? According to Friedrich Kill 2020, bioplastic are plastic products derived from renewable biomass sources such as wood chips, straw, vegetable fats and oils, sawdust and recycled food waste. The term bio-based is referred to plants that can be significant sources of polysaccharides such as cellulose, starch and pectin. According to Ismail 2060, potatoes and yam tubes are popular sources to synthesize plastic. Let's move on to the main contents of this review, which is to discuss the effect of natural pH indicator to the properties of biofilm. The natural pH indicator here is Anthocyanin, and first properties would I discuss here is thickness. Based on my findings, I found that February research and Putra research by using dragon fruit extract as the indicator to the cassava starch and scagium oleina film shows that the thickness is increased once they added that indicator. This trend of increasing also valid for Chai and Preto research in 2017 by using rosella extract and red cabbage extract and black bean as the indicator to polyvinyl alcohol PVA and cornstarch. However, the trend is completely different for Satyadi research. 2016, they used rosella extract as the indicator to added to the starch glycerol film, and the thickness of biofilm show no effect. This trend also continued in 2020 by applying better leaf as indicator to a starch film. To discuss more further about mechanical properties, we can also discuss in terms of tensile strength properties. So based on my findings, I found that Brie and Satyadi used dragon fruit extract and rosella extract as indicated to cassava starch and starch glycerol film respectively. They found that the tensile strength value is increasing. This trend also valid for Suzy Haikul 2019 research. However, the trend research conducted by Latus Program Masih 2019, Ma Chai Preto 2017 and Koja Behavior 2016, which show the decreasing in terms of tensile strength. Basically, yam modulus is dependent on the morphology and compositions of the polymer. So based on my findings, I found that Putra and Yoshida in 2017 and 2040 showing that the yam modulus value is being reduced. However, this decreasing effect was increasing in terms of research done by Satyadi in 2060 and Yoshida 2040 and Satyadi. Properties can be discussed in terms of elongation. Elongation is defined as the change of length of sample due to the force exerted by a strap. Based on my findings, I found that a research conducted by February by using dragon fruit extract as indicator added to the cassava starch film, they show that elongation value is decreasing. This trend is also valid for a research done by Yoshida 2040, Liu 2018, Ma 2070 and Satyadi in 2020. However, research done by Satyadi in 2060, elongation value is increasing. This is also valid for research done by Chai in 2070. However, there are constant value for elongation. Research done by Preto in 2070. Barrier property explained in terms of water content or water permeability effect. So, based on my finding, I found that research done by Yoshida in 2040, Liu 2018, Satyadi 2020, as well as Zhang 2019, they're showing that water content is being reduced or being decreased. However, this trend is increasing when the research is conducted by Ma 2017. The trend interestingly changed when research done by Silva Pereira in 2040 and Chen 2020. Water content is remain constant or no change. It can be concluded that Anthocyanin can serve as a bioactive compound. This review summarized the chemistry of the anthocyanins and how the inclusions of fat structure can affect the biofilm property. In my opinion, the additions of anthocyanin to the bioplastic can improve the biofilm's quality and productivity. It is recommended for the researcher to study this particular topic furthermore comprehensively and explore the various plants that contain anthocyanin or any other natural pH indicator, so that we will know the benefit of adding a certain percent to the biofilm to act as an intelligent integrated film in the future.